Good morning, friends. This is a small presentation on psychrometry. Psychrometry, you understand, is a study of properties of moisture. So, the outcome of the lecture or this video is to brief you about the psychrometric terms which are used. The object is not to explain those terms in detail. The understanding of these terms, the psychrometric terms, would be useful in calculation of the psychrometric properties, and this psychrometric properties we'll be learning how to calculate by using steam tables and not the psychrometric chart. Please note. So what is the outcome we are expecting here? We are expecting that we would be learning how to determine especially the partial pressure of water vapor using the steam tables. And once you know the partial pressure of water vapor using the steam table, learn how to calculate the other psychrometric properties. So psychrometry, as I said, is the study of properties of moisture, the air which is being conditioned. This conditioned air, we use certain terms to denote its parameters, and those terms of moisture are known as psychrometric terms. So we are familiar with those terms. I'll just do a quick recap of those terms before we actually learn how to calculate the psychrometric properties using the steam tables. So the important parameters or important properties in psychrometry, they are these three. These are the three different temperatures. One is the dry bulb temperature, other is the wet bulb temperature, and third is the dew point temperature. This you know already that dry bulb temperature is the temperature which we record using your thermometer, regular thermometer. And what is the difference between these temperatures, wet bulb and dry bulb? So wet bulb temperature is recorded. It can be recorded using the same thermometer. What modifications we need to do? We need to surround the bulb of this ordinary thermometer with the weight cloth or weight wick. So if you do this exercise and again record this temperature, you will find that this temperature would be different generally than the dry bulb temperature. This would be lower than the dry bulb temperature. So that temperature is known as wet bulb temperature. The moist air which we are talking about, your ambient air which we are interested in air conditioning, it is always moist. It will contain certain moisture in it. And that moisture which is present in the moist air, we need to clearly understand that this moisture is not in the liquid form. This moisture is not in the liquid form. I am repeating this. This moisture is in the form of vapor, superheated vapor. So this superheated vapor which is there in the moist air, if you cool that ambient air in a air conditioning equipment at certain temperature, when you are cooling it, that superheated vapor becomes saturated and ultimately your dew drop is formed. So the temperature at which the water vapor which is present in the moisture, it starts condensing, starts becoming dew, is known as the dew point temperature. So these three are the central concepts in your psychrometry: dry bulb temperature, wet bulb temperature, and dew point temperature. And you don't record dew point temperature. What you record is generally the dry bulb temperature and wet bulb temperature using a sling psychrometer. These are the other terms which are equally important, and these are especially important because we would be using these terms again and again while solving the numericals on psychrometry. So I'm using these terms PV and PVS. I'm adding this alphabet S to PV. So this S would indicate saturated air, and all our regular ambient air would be unsaturated. So if I measure the pressure of not the total air but of the water vapor in it, if I measure the pressure of not the total air but of the water vapor present in it, then that pressure of the water vapor is known as the partial pressure of water vapor. If I take saturated air and do the same exercise means what? If I again measure the partial pressure of water vapor in it, that would be called as PVS, right? So PV is what? PV is the partial pressure of water vapor, and PVS is what? It is also the partial pressure of water vapor, but then here is saturated. Here is saturated. The other term of interest is omega. Omega is the specific humidity. As the term indicates, it is humidity per unit mass of dry air. So it is humidity or water vapor present or water vapor associated with 1 kg of dry air. So this is again a very important psychrometric term. Specific humidity is it gives you an idea of how much water vapor is present in the given moist air. Relative humidity and degree of saturation, these are also some terms which help you understand humidity with reference to the saturated air. So relative humidity we talk about with reference to saturated air. Degree of saturation also we talk about with reference to saturated air. So how do we define those two? So relative humidity is the ratio of PV upon PVS. It is the ratio of partial pressure of water vapor upon partial pressure of water vapor if the air is saturated at the same temperature. At the same temperature. Similarly, degree of saturation is what? It is the ratio of specific humidity at a given temperature upon specific humidity of the same air at the same temperature. The difference is the air is now saturated. The air is now saturated. So omega upon omega s is degree of saturation and PV upon PVS is the relative humidity. Generally, the weather stations, they would tell you this thing. What is the relative humidity? So if you read any newspapers and the weather column in it, then you will find that generally they would give you what is known as the relative humidity of the ambient air in that particular season, particular day. So we are interested in learning how to solve numericals of psychrometry using the steam tables, getting the properties using the steam tables. So I categorize the numericals into two types. There are many types, but these two types of numericals are generally encountered. And what are those two types? So you would find that in the given problem, generally they would give you the dry bulb temperature and wet bulb temperature. Means what? If I want to design a air conditioning equipment, then what I do is that I use a psychrometer and record the dry bulb temperature and wet bulb temperature. So if you get this dry bulb temperature and wet bulb temperature, then using the method which I will be discussing now, that is using steam tables, I would then be able to calculate the vapor pressure. I would be in a position to calculate the dew point temperature, the specific humidity, relative humidity, enthalpy, etc. So by simply noting down the dry bulb temperature, wet bulb temperature, and by recording the pressure using the barometer, I can find the remaining properties not by using psychrometric chart. I can use the psychrometric chart also and find it, but the discussed method is we would be finding these properties by using the steam tables. This is one type of problem. The other type of problem is you know the dry bulb temperature and you know the dew point temperature. So if you know the dry bulb temperature and if you know the dew point temperature, then how to find the partial pressure of the water vapor, how to find the specific humidity, how to find the relative humidity, how to find the enthalpy, etc. So these are the two broader types of problems which we encounter. Which are the two types? One is when your dry bulb and wet bulb temperatures are known, and other is when your dry bulb and dew point temperatures are known. Right? And how to solve them? So for this, let us, for example, if I want to find specific humidity. So how do I find specific humidity? Not from the psychrometric chart, but from the steam tables. So you'll see that Specific humidity omega is given as this expression. How do you get this expression? This expression can be derived from the first principles, from the definition of specific humidity. What is the definition of specific humidity? It is the kg of water vapor upon kg of dry air. So if we use the gas law, PV is equal to MRT and PV is equal to MRT, and substitute the appropriate constants of R, then you will find that you will get this expression 0.62. So this is left as an exercise. You can try this derivation at home, where you can derive from the first principles the relationship between omega and partial pressure of water vapor. So if you know the partial pressure of water vapor, by using this expression you can calculate the specific humidity. Now the central point is, how do you get this partial pressure of water vapor? Because this P, how do you get this P? This P we are measuring by using the barometer. Are we measuring PV? No. So we need to calculate that. How do you calculate it? Using the steam table concepts, that is to be understood. So PV is the partial pressure, which can be found by two methods. One is by using the Carrier's equation. If the WBT is known, this is one type of problem, that if you know the wet bulb temperature and if you know the dry bulb temperature, then you can find PV by using an empirical relation known as Carrier's equation. Carrier, you know, is a person who is responsible for developing the science of air conditioning, is honored by naming him as father of air conditioning. So Carrier, in the honor of his work in air conditioning, we call one empirical relation as Carrier's equation, and that Carrier's equation we can use for determining the partial pressure of water vapor PV. This is one method. And when can this method be used? If your wet bulb temperature is known. But if your wet bulb temperature is not known, and instead if your dry bulb temperature is instead if you know the dew point temperature, then one can get this PV directly from the steam tables. How, that we'll discuss shortly. So the first type, when we are saying that I know, okay, I am measuring the dry bulb temperature T and the wet bulb temperature T dash. So what you know is, now you know the dry bulb temperature T and the wet bulb temperature T dash, and what is to be found out? We are supposed to calculate the partial pressure PV. How do you get dry bulb and wet bulb temperature? This can be easily measured, right? How can we measure that? Psychrometer, correct? Now suppose you know T and you know T dash. Look at this equation. You see that you can substitute T and T dash in this equation. You can substitute P in this equation, and you need to find PV dash. So what is this PV dash? What is this PV dash? So PV dash can be obtained from the steam tables. And how to get this PV dash? You know that in the steam tables there are two columns. One is the pressure column and next to it is the temperature column. So if you see the temperature column corresponding to the pressure, that temperature is called as a saturation temperature. If you see the pressure column corresponding to the temperature, that pressure is called as a saturation pressure. Now what we know? Do we know the pressure? No. What do you know then? You know the temperature. So you know the wet bulb temperature T dash. So let us say the wet bulb temperature T dash is 20 degrees centigrade. 20 degrees centigrade. Now you just pause this video, open your steam tables and convince yourselves what is that in the column of pressure corresponding to 20 degrees centigrade. You'll find that corresponding to 20 degrees centigrade in the steam table, you will have this value. So this value is known as PV dash. So what is this PV dash? PV dash is the saturation pressure corresponding to the wet bulb temperature. Okay, so now it is very easy mathematically. If you look at this problem mathematically, how to find PV? Use this equation. And what are the unknowns? P is known because it is total pressure. It is given. It can be measured by barometer. T is known. It can be measured using dry bulb thermometer. T dash is known. It can be measured by using the wet bulb thermometer. Then what is unknown? PV dash is unknown. And how do you get PV dash? You get PV dash from the steam tables. Once you get PV dash, you can easily calculate using this expression PV. So partial pressure of water vapor is determined. This is method when you have dPt and WPT as known. What if WPT is not known and instead of that dew point temperature is known? Then it becomes very easy. Dew point temperature is known and you want to find PV. What you need to do? Again, for example, let us say the dew point temperature is 15 degrees centigrade. 15 degrees centigrade. Now what you need to do? Go to the steam tables. You can see, pause this video, open your steam tables and look for the column of pressure. So you'll find that in this column of pressure corresponding to 15 degrees centigrade, this value would be there, 0.1704 bar. So what is this value? This is PV value. Now this mechanically can be understood that what you need to do mechanically, you know the dew point temperature, open the steam table, get the value PV from the steam table directly. But why is that so? For that we need to understand the concept well. As I said, the moisture contains water vapor and the water vapor is in the superheated form. It is in the superheated form. It is the water vapor is in superheated form. So what is dew point temperature we said? We said that if you go on cooling that superheated vapor corresponding at constant pressure, that is PV pressure, then a point would be reached, a temperature would be reached when the water vapor would start condensing. So the temperature when the water vapor starts condensing is known as dew point temperature. So it means that the saturation temperature corresponding to PV is nothing but the dew point temperature. So saturation temperature corresponding to PV is the dew point temperature, or the saturation pressure corresponding to dew point temperature is PV. Same way, 15 degrees centigrade the pressure is 0.01704 bar, and if you look at 0.01704 bar, the corresponding temperature is 15 degrees centigrade. So one of it is known, the other can be easily calculated. So if you know PV, you can calculate dPt directly from the steam tables. If you know the dew point temperature, one can easily get the partial pressure of water vapor. Right? So if your dew point temperature is known, simply refer to the steam table, look for the saturation pressure corresponding to the dew point temperature, and that is directly the partial pressure of water vapor. That's it. So we have understood how to get PV. Once you get PV, the other properties, namely the relative humidity, specific humidity, vapor density, or degree of saturation, can be easily computed by these relations. Okay, in this relation, apart from PV, you will find that the other parameter is PVS. PVS, as we discussed, is what? It is also the partial pressure of water vapor. It is also the partial pressure of water vapor, but the air is saturated. So how do we get the value of PVS? PVS we obtain from the steam tables again. PVS we obtain from the steam tables again by looking for the saturation pressure corresponding to what? Please note, corresponding to dry bulb temperature and not the dew point temperature. Please note. How do you get PVS? Saturation pressure corresponding to dry bulb temperature. So if you record the saturation dry bulb temperature using the thermometer, and if you refer to the steam tables, the pressure value corresponding to that dry bulb temperature is your PVS. Once you get PVS, we have studied how to get PV, you will get the ratio as a relative humidity. Similarly, knowing PV, knowing the total pressure, you will get the specific humidity. Similarly, by knowing PV, knowing the vapor constant, knowing the dry bulb temperature, one can find the vapor density or absolute humidity. And again, by knowing PV and PVS, we can find the degree of saturation. So you see, what was the central point? You have to determine partial pressure of water vapor. Once you get the partial pressure of water vapor, PV, and once you get the partial pressure of water vapor, PVS, you can find these four other properties directly. So as I said, please note that the problems of psychrometry generally, okay, using the steam tables, they are reduced to determination of PV and PVS. If you are able to determine PV and PVS, then you can get most of the properties directly by using these relations. How to find the enthalpy, that we'll see later. So if you have understood these concepts, and I hope that you have really understood them, I would recommend that you solve these two numericals. If you are able to get these values correctly, then I feel that the outcome of this lecture has been achieved. So I have tried to simplify and conceptualize the concepts in a short video. When we meet personally in the class, we would understand this more better. I thank the Corona break for giving me this opportunity of recording this lecture. Thank you and enjoy.